Okay, so lesson 2.4, finding max and mins of polynomial functions. So these would be like real world examples of max and mins. Okay, the first 3 slides, all of these are warm-ups. Okay, this should, be number 2. So please complete those. We will check those at the beginning of class tomorrow. Okay, so maxes and mins, an example of this. 2 numbers have a difference of 6. Find their minimum possible product. Okay, so if 2 numbers have a difference, what does that mean? So finding a difference is subtracting 2 values. So if x minus y is equal to 6, I want to know what the minimum possible product is. So what's my product? My product is x times y. So that's the value that I want to be the minimum. Okay, so let's be aware of what this whole unit has been centered on. It's been centered on quadratics, right? So if I have a quadratic, how do I find my max or min? My max or min is my vertex. Okay, so the x-coordinate of my vertex, negative b over 2a, and then to get my y value, that's when we would plug it in. So for this lesson, you got to be thinking, okay, can I write a quadratic formula? So right now, my product is not a quadratic, but I can get a quadratic by using this first piece of the given information. Here I have an equation that has x and y. So I'm going to solve this equation for x by just adding y to both sides. Now into my product equation, I'm going to replace x to be the expression in terms of y. So now look at what I have. Now I have an equation that's strictly in terms of one variable, and if I distribute that y, I get 6y plus y squared. So now if I want to find the minimum, what's the minimum? The minimum is the vertex. So the vertex here, my variable happens to be y, so y would be negative b over 2a. So my y value is going to be negative 3. So now how do I go back and get my x value? My x value will be 6 plus, I just found that to be negative 3. So my other coordinate is going to be positive 3. So what's their minimum possible product? Negative 3 times 3 would be negative 9. So that's the smallest that the product could be. And then what are the 2 numbers with the minimum product? We're working backwards here. My 2 numbers are 3 and negative 3. Okay, this is from the textbook, number 1. A farmer wants to make a rectangular enclosure using a wall as one side and 120 meters of fencing for the other 3 sides. Express the area in terms of x and state the domain of the area function. Find the value of x that gives the greatest area, and then what is the actual greatest area. Okay, so 120 meters. Couple things here. You got to use your units to guide your answer. So if I'm talking about just single units, meters, that represents my perimeter. So here I have this wall where one side is the barn wall, making the fencing, the enclosure is actually only going to have 3 sides to it, okay? Because we don't need to build anything on the wall where the barn already is. Okay, so if this length is x, this length is x. Well, what do I know the total amount of fencing that I have, or whatever he's going to use to build the wall? My total perimeter for these 3 sides is 120 meters. So what's this remaining side going to be? It's going to be the 120 meters that I have minus these 2 x's, because we're told that the one wall has a length of x. So express the area in terms of x. So the area of a rectangle is length times width. But now in terms of x means x has to be the variable in my equation. So what are my dimensions that we just drew? X times 120 minus 2x. Okay, now again, is it a quadratic? It is. So I'm going to distribute that x from the outside, and now I have an area function that's a quadratic. So now we're able to find a vertex of that. Okay, state the domain. So the domain represents all the possible values of x. Okay, so we're talking about length, distance, building. So we know that x has to be greater than 0. I can't have a length of 0 and it can't be a negative either. So then my other restriction comes from my third side here. So I know that this guy has to be bigger than 0. So when I solve this for x, 120 is greater than 2x. So then x has to be less than 60. So my domain, notice I can't equal those numbers because again, my lengths can't equal 0. We write our domain to be between 0 and 60. Okay, and we'll talk about this notation in class. This does not, so let me write this. This does not represent the point x equals 0, y equals 60. This is known as your interval notation. And in words, it would mean that x is between 0 and 60. And for our word problem, our units are meters, so between 0 and 60 meters. Okay, so let me come over here. Find the value of x that gives the greatest area. So from part A, we said the area was equal to 120x minus 2x squared. So greatest, this is really saying find the maximum. Okay, so my vertex, x equals negative b all over 2a. So I get negative 120 divided by negative 4. So 30 meters is going to be the value of x that'll maximize my area. Okay? Now think about what your maximum is. So we know that our vertex is x comma y. Recall from unit 1, x represents where it occurs. Y represents what it actually is. So to answer part C, okay, so this was B. So to answer part C, to find the area, I want the area when x is equal to 30 meters. So now into my function, I'm going to replace all my x's with 30. Now I'm going to go back and factor it because I think this is a little bit easier to plug in. So I get 30 times 120 minus 2 times 30. This gives me 30 times 2 times 30 is 60. 120 minus 60 gives me 60. So when I multiply that, 3 times 6 is 18, and I add my 2 zeros. Now my units, I'm talking about area, so my units are meters squared. Okay, so notice the difference in the answers between B and C. Part B is asking what value will maximize it. Part C is asking what the actual maximum is. Okay, next one, this is number 9 from the text. If a ball is thrown vertically upward at 30 meters per second, then its approximate height in meters t seconds later is given by the function. Okay, so let's check this out. So ordered pairs are in the form t comma h of t. Okay, t is my unit of time, so that's measured in seconds. H of t represents my height, and my height is measured in meters. Okay, and I know that from this little piece of information right there. After how many seconds does the ball hit the ground? So when will it hit the ground? The ball hits the ground when the height is equal to 0. So for part A, I'm setting my function equal to 0. And solving for t. Okay, t just happens to be my variable here. Two terms, they have a 5t in common. So when I factor that out, I'm left with 6 minus t. So setting those equal to 0, I get 0 seconds. And I get 6 seconds. Well, this makes sense. Think about t is equal to 0. If the ball is thrown vertically upward, then before it's thrown, the height hasn't gone anywhere. So the object starts on the ground. So after how many seconds does it hit the ground? After 6 seconds, the height comes back to 0. And let's think about what this looks like. It's a downward facing parabola. So at time t is equal to 0, I'm on the ground. At time t is equal to 6, the projectile has gone up, come back down, and landed back on the ground. Now what's my domain of h? Okay, so I know my x values go from 0 to 6. Now the difference here, we can actually equal these values. So I'm on the interval from 0 to 6, but now because I can equal those numbers, I put hard brackets around my two values of t, as opposed to number 1, where I couldn't include 0 and 60, and therefore they look more like parentheses, they're soft brackets, then I can't equal those numbers. But on this one, I can let x or time equal 0 and 6. All right, and then lastly, C, how high does the ball go? So how high does the ball go? That's asking us to find the vertex. Okay, so to find the vertex, my x-coordinate is negative b all over 2a. So I get negative 30 divided by negative 10. So now notice what we found. We found our unit of time. So this is saying after 3 seconds, the ball has reached its maximum height, but you got to answer the question. What is the actual height of the ball? Then we got to take that 3 and plug it back into our original function. So 30 times 3 minus 5 times 3 squared. So I get 90 minus 3 squared is 9. 9 times 5 is 45. So its maximum height is 45 meters. So that would be the actual answer to part C. Okay, I will not go on to the next problem. We will go over the warm-ups, talk about these, and then we'll look at the volume together.